Now we pick up with the first section of our chapter 14, and this chapter will be on the Federal Reserve System. So first of all, what is the Federal Reserve System? Well, often referred to as the Fed, the Federal Reserve System was created only in 1913. So before 1913, the United States did not have a Federal Reserve System or did not have a central bank. Now, our meaning the United States' particular central bank, known as the Federal Reserve, acts as a bank for other banks. So it's run by the government and it serves multiple functions. And here's some of them we have listed right here on our slide. It has a check clearing function so that when you write a check in your bank, at your bank here in Atlanta, but you're on vacation in California, and you write a check and buy something in California, obviously the banks have to communicate with each other somehow to get that check sent back to Atlanta, get it cleared so that both parties can get the money transferred to them. So check clearing is a major function of the Federal Reserve. They also hold bank reserves. Banks not only can keep reserves in cash in their own vault, but they can also keep it on deposit at the Federal Reserve System, and nice and safe and secure, and that's where they can keep it. The Federal Reserve provides currency, and it also provides loans. But unlike normal banks, which can provide loans to consumers and business people and other institutions, the Federal Reserve System can only make loans to other bankers. So it's kind of like a wholesale operation rather than a retail operation. Now, the Federal Reserve Board of Governors, they're the folks who oversee the running of the Federal Reserve System. They set something called monetary policy. And monetary policy is the use of money and credit controls to influence the macroeconomic outcomes of the economy, things such as what the inflation rate is, what the economic growth rate is, things like that. That would be very important for the Federal Reserve. Now, there are 7 members of the Federal Reserve who are appointed by the President and confirmed by the Senate, which is a very common thing to do in the United States for high-level government appointments, and they serve 14-year terms. But the terms are staggered so that they come up every 2 years, and that means that any incoming president cannot just simply fire the Board of Governors and appoint all new board members. So every president has a holdover over many years and of previous administration's Federal Reserve members, the Board of Governor members, and this was done deliberately to maintain some level of political independence. Now, one of the board members is appointed by the president to serve as the chair, and that chair serves for a 4-year term. With the current Federal Reserve Governor, is Jay Powell at the time of this particular lecture. Now, in figure 14.1, we look at the structure of the Federal Reserve System. In this picture, you can see that we have the Board of Governors, the 7 members that I mentioned are at the top of the pyramid. There are Federal Reserve banks that are chartered in different regions of the United States. We have one here in the Southeast and is headquartered here in Atlanta. And the Federal Reserve, the bank presidents of the Federal Reserve System serve on the Federal Open Market Committee, as well as all the Board of Governors members. Now, you can see those numbers are not going to add up, because if we have 12 Federal Reserve banks, that means we have 12 Federal Reserve Bank presidents and 7 Federal Board of Governor members. That would add up to 19. So it turns out that all 7 of the Board of Governors members always serve on the Federal Open Market Committee, and then 5 other positions are rotated among the remaining 12 Federal Reserve Bank presidents. So they alternate when they get to stay on the committee. And then beneath all of them are the private banks or depository institutions that the Federal Reserve oversees. Now, let's take a look at the Federal Open Market Committee. This is probably the most important of the committees that the Federal Reserve System has, and it's responsible for the Fed's daily activities in financial markets. And the Open Market Committee gets its name from the fact that they participate in what's called the open market, which is just the financial markets on Wall Street. So the Federal Open Market Committee would be either borrowing money or lending money on a daily basis to try to influence the total amount of money supply. Now, as a committee, they meet every 4 to 5 weeks to get their direction, and the members, as I've already pointed out, are the 7 members of the Federal Reserve Board, plus 5 of the 12 regional bank presidents who are on a rotating basis. Now, what are the monetary tools? The monetary tools are mechanisms that the Federal Reserve has to control the money supply. There's three of them. They can control the money supply through controlling the reserve requirements, by controlling what are called discount rates, and controlling open market operations. Let's go ahead and focus on the reserve requirements. Now, as we've pointed out earlier, back in Chapter 13, private banks are required to keep a fraction of their deposits in reserve, either as cash or as a deposit at a regional Federal Reserve bank. Now, the Federal Reserve sets the required reserve ratio. Now, remember, banks cannot lend out these required reserves. By the very definition of them, they are required to be kept in reserve, in cash, or as a deposit at the Federal Reserve Bank, where they cannot be lent out. So banks can lend out the excess amount of reserves they have, but they cannot lend out the required reserves. Now, how do we calculate how big the required reserves are? You see in the bottom square here, we have a formula. So the required reserves are the required reserve ratio, which will be a decimal number, times the total deposits. So let's assume that the Federal Reserve has put a 10% reserve requirement. You would take 10% as the required reserve ratio, or 0.10, times the total number of deposits, and that tells you what percentage you need to keep in cash in the vault. Now, what's interesting here is we're going to be looking at something called excess reserves. Banks could very well have more cash in their vault than they legally are required to keep. And the excess reserves are the money that's available for banks to lend out, since they can't lend out the required reserves. So how do we define excess reserves? Well, the total reserves, which are cash in the bank, minus the required reserves, which is what the Federal Reserve requires them to keep, whatever the difference between those two numbers will be excess reserves. And excess reserves can be lent out. So let's just run through a quick couple of examples I've got here on our slide. In example one, let's assume the bank has $100 billion in deposits, and it's a brand new bank, so they've not made any loans yet, so all the money is literally sitting in the vault in deposits. So we're assuming the Federal Reserve sets the required reserve ratio at 20%. Then we can do the math pretty simply. You could get out a pencil if you wanted to, but you should be able to do it in your head. If they have $100 billion in deposits that are sitting in reserve in the vault, they're only required to keep 20 billion, because that's 20% of 100 billion. That must mean they must have excess reserves of 80 billion. That would just simply be the 100 billion in total reserves minus the 20 billion of required reserves. Let's do a different example. Let's assume the bank holds 100 billion in deposits, but it's been in business for a few years and has made $65 billion in loans. That means it still has $35 billion sitting in the vault that's never been lent out. So let's take a look at the reserve requirement, still 20%. Is it 20% of the 100 billion in deposits, or is it 20% of the cash sitting in the vault? Well, it's of the original deposits, so it's 20% of 100 billion. So they're required to keep 20 billion out of the 100 billion that were originally deposited. But remember, a big chunk of the 100 billion has already been lent out. 65 billion of it has been lent out. So they're required to keep 20 billion, which means what? 80 billion of the 100 billion is available to be lent out. They've lent out 65 billion, so they must have what? Excess reserves of 15 billion. Unfortunately, my little picture thing is covering up the excess reserve number. If you need to look at that, that number is 15 billion, because that's the difference between the amount of cash that is still sitting in the vault, which would be what? 35 billion, and the 20 billion that is required to be there. So they have excess reserves of 15 billion. Now, why is that important? Because lending capacity is ultimately determined not by the total amount of cash you have in the vault, but by how much of it is excess above the amount that you are legally required to keep in the vault. So let's just go ahead and jump to the very bottom in the little square. We have a formula. So available lending capacity for the entire banking system will be the amount of excess reserves held by all the banks times the money multiplier. Remember what we worked through in Chapter 13. We recognize that the process of lending itself creates money. I'm not going to go back through the whole thing all over again, but you might need to go back and review Chapter 13 on this issue. But we were able to demonstrate through a couple of examples that when banks lend money, the person that deposited the money still believes the money's in their account, even though the money's been lent out to somebody else. So multiple people are counting the same money as their deposit. So obviously there's more deposits than the original amount of printed cash that was originally put in the bank. So that's what we mean by the money multiplier. So if the banks have excess reserves and start lending it, those lent excess reserves will turn into money supply as people believe that money is in their account, and therefore the excess reserves will expand by the amount of the money multiplier. So remember the formula for the money multiplier. That was 1 over the reserve requirement. So if the reserve requirement is 20%, 1 divided by 0.20 is 5. So the money multiplier would be 5. 5 times the excess reserves. In the example we did, we had 15 billion in excess reserves. So 5 times 15 would give you the total amount of actual lending capacity. So whenever the reserve requirements are raised, then the money multiplier goes down. Remember, if the formula says it's 1, the money multiplier formula is 1 divided by the reserve requirement. If you raise that number from, let's say, 0.20 to 0.25, 1 divided by 0.25 is only 4. So the money that's in excess when it gets lent will only expand 4 times instead of 5 times. But if you decrease the reserve requirement, as it shows in the second column, then the money multiplier increases. Let's reduce the money multiplier to 10%. So 1 divided by 0.10 is 10. So if you have excess reserves of 15 billion, then 15 billion times 10 would give you 150 billion. Whereas before, when it was 20%, we only grew to 75 billion. So you can see that if the Federal Reserve decreases the reserve requirement, we would expect the money supply in the entire country to expand as banks lent out all these excess reserves. Here in our last slide on this particular set of slides, we're going to compare with the exact same bank under 2 different reserve requirements. We see that there is a 20% reserve requirement or alternatively a 25% reserve requirement. Now let's assume that both banks have $100 billion deposited. So that's our first number, 100 billion. Now the total reserves happen to be 30 billion because the bank has lent out 70. We're just assuming that. So they have $30 billion. But what are they required to have? You notice in the first column, if it's a 20% reserve, then 20% of 100 billion is 20 billion. That's where this number right here is coming from. The $20 billion number is the required reserve for the first bank. But what if the reserve ratio was 25%? Then you would have what? 25 billion would be the required reserve. Now remember, both banks have 30 billion sitting laying around in cash. So if this bank is required to have 20 billion, then they must have what? 10 billion in excess reserves. Whereas this bank only has 5 billion in excess reserves because it also has 30 billion in cash, but is required to keep 25 billion due to a higher reserve requirement. So even though both banks have the same size deposits and the same amount of cash laying in the vault, each one of them has different amounts of excess reserves. And then when you take a look at the money multiplier, in a world of 20% reserve requirements, the money multiplier is 5, 1 divided by 0.20, whereas in a 25% world, it's only 4, because 1 divided by 0.25 is only 4. So if you took this 10 billion times 5, that gives you the unused lending capacity from the formula on the previous slide. So this bank could lend out 50 billion. This bank could only lend out 20 billion because you would have what? 5 billion of excess reserves times 4 would give you 20. So you can see even very small differences in the reserve requirement. Remember, it only went from 20 to 25%, triggered a situation where lending changed from 50 billion to 20 billion. So the Federal Reserve could have a major decrease in the total amount of lending going on by raising the reserve requirement by a relatively modest 5 percentage points. Or vice versa. They could lower the reserve requirement from 25% to 20 or 20 to 15, and it would have a major increasing ability of banks to lend that money out and therefore increasing the money supply.